In our lesson today, we're going to learn about square roots and cube roots. And we're going to start off with square roots. A square root is the inverse operation of squaring a number. Said another way, we want to know which number multiplied by itself is equal to the original number. Okay, the symbol for a square root will look like this, where x is a non-negative value. Okay, the number that's underneath this symbol here can only be a positive number or zero. And example number one asks, why is an exponent of 2 called squaring? Well, this term comes from finding the area of squares. All right, we all know from a picture of a square that all four sides have the same measurement on a square. And if you were looking for the area of a square, you would use the formula area equals base times height. Since the base and the height have the same dimensions, in this example, I would say that base times height, we're just going to do 4 times 4. Well, 4 times 4, if it's repeated multiplication, you can write with a single base of 4 raised to the second power, where again, the exponent tells you how many copies of the base you're going to multiply together. So area equals base times height, which is 4 times 4, or in this case, 4 to the second power, 4 squared, which means that the area here is equal to 16 square units. Okay, so whatever the units happen to be in this example, we will square those. If I were to tell you the area of the square, you would be able to tell me what the side lengths have to be. In this case, since the area is 16 units squared, the side lengths have to be 4 units each. Finding a square root, again, is the inverse of squaring a number. In other terms, if you are provided with the area of a square, then you can determine the length of each side of the square. Okay, so in this example, all right, since the area is equal to 16, if I wanted to figure out what the side lengths were, I would have to take the square root of 16, and the square root of 16 is equal to 4, all right, because 4 times 4 equals 16. All right, what number did I multiply by itself in order to get 16? Well, that number was 4. So the square root of 16 is equal to 4. Now that we have a basic idea of square roots, our focus today is going to be on approximating square roots. When the square root of a number is a whole number, this number is called a perfect square. Perfect square. All right, in the example that we did above right here, all right, when I took the square root of 16, I got a whole number of 4. That means the number that I took the square root of, in this case 16, is called a perfect square. All right, so 16 is a perfect square because, again, when I take its square root, I get a whole number. Now, is every number a perfect square? Well, of course not. No, not every number is a perfect square. Many numbers are non-perfect squares because the square root of that number is not a whole value. Take, for example, the square root of 3 and the square root of 7. If I were to use my calculator and type in the square root of 3, second x squared of 3, there we go, square root of 3. Well, notice that I get this long decimal. In fact, let's write those digits down. 1 and 732,050,808. Okay, what about square root of 7? Square root of 7. And again, I get this other long decimal here, 2 and 6,457,51311. These values are definitely not whole values. Okay, so if I take the square root and I get a number that's not a whole value, the number underneath of the square root symbol is not a perfect square. How would you describe these decimals? Okay, well, these decimals seem that they're going on forever and they don't seem to be repeating in a specific pattern. So I would call them non-terminating and non-repeating. Okay, these decimals are non-terminating and non-repeating. They go on forever without repeating in a pattern. That means that the square root of a non-perfect square is an irrational number. Remember that irrational numbers are decimals that are non-terminating and non-repeating. Anytime you take the square root of a number that's not a perfect square, you're going to get a non-terminating and non-repeating decimal. Example 2 asks between which two integers is the square root of 5? And then they also want to know which integer is square root of 5 closest to. All right, well, 5 itself is not a perfect square. If I were to take the square root of 5, I would get a non-terminating, non-repeating decimal, better known as an irrational number. In order to figure out the two integers that the square root of 5 is in between, what I'm going to do is try to figure out what are the perfect squares that 5 is between. Okay, so 5 is in between which two perfect squares? Well, in class, we're going to be filling out a perfect squares chart, which is going to look something like this. This is my completed perfect squares chart. All of the numbers in this column are perfect squares, like 1, 4, 9, 16, 25, 36, 49, etc. Okay, these are the list of perfect squares. I want to find the perfect squares that 5 is between. And looking at my list up here, I can see that 5 is between the numbers of 4 and 9. 4 is a perfect square because 2 times 2 is 4. 9 is a perfect square because 3 times 3 is 9. 5 is in between 4 and 9. So I can say that 5 is in between 4 and 9, which again are perfect squares. So if I were to take the square root of 5, then I would have to take the square root of my other numbers as well. And that means that the square root of 5 is going to be in between the square root of 4, which is 2, and the square root of 9, which is 3. All right, the square root of 5 is in between 2 and 3. Now I want to know which of these is it going to be closer to? Okay, is square root of 5 closer to 2 or is square root of 5 closer to 3? Well, in order to answer that question, we're again going to look at the perfect squares of 4 and 9. Is 5 closer to 4 or closer to 9? Well, 5 is only 1 away from 4, but 5 is 4 away from 9. Therefore, 5 is closer to 4, so the square root of 5 is closer to the square root of 4, which is 2. Square root of 5 is between 2 and 3, but it's closer to 2. All right, let's try that again with a different example. Between which two integers is the square root of 76? Which integer is the square root of 76 closest to? So just like I did before, I have to figure out 76, that's my number underneath the square root symbol. If I took the square root of that number, I would again get an irrational number, all right, which is a non-terminating, non-repeating decimal. But which perfect squares is 76 in between? So if I remember from my list here, okay, here's my list of my perfect squares here in this column. All right, 76 is going to be in between 64 and 81. These two numbers are perfect squares. 8 times 8 is 64, 9 times 9 is 81. 76 is between 64 and 81. So 64 is less than 76, 76 is less than 81. Now, if I took the square root of 76, I would have to take the square root of the other two numbers. So the square root of 76 is between the square root of 64, which is 8, because 8 times 8 is 64, and the square root of 81, which is 9, because 9 times 9 is 81. The square root of 76 is between 8 and 9, but closer to which of those? Okay, so is it closer to 8 or closer to 9? Well, again, look at the perfect squares of 64 and 81. 64 and 76 are 12 apart. 76 and 81 are 5 apart. So square root of 76 is closer to the square root of 81, which is 9. Square root of 76 is between 8 and 9, but closer to 9. In our next example, we want to know between which two integers is the square root of 221. So again, when I take the square root of 221, I'm going to get an irrational number, a non-terminating, non-repeating decimal, because 221 is not a perfect square. What I'm going to do is figure out the perfect squares that 221 is in between. Okay, so again, if I look at my list of my perfect squares, all right, square root of 221 is between which two perfect squares? All right, well, here's my list of perfect squares in this second column right here again. All right, 221 is going to be between 196 and 225. These two numbers are perfect squares. All right, 221 is between 196 and 225. 196 is less than 221. 221 is less than 225. Now, if I take the square roots of the numbers, all right, that means the square root of 221 has to be between the square root of 196, which is 14. 14 times 14 is 196. And also square root of 225, which is 15. 15 times 15 is 225. The square root of 221 is between 14 and 15. Okay, and then in our example underneath, which integer is square root of 177 closest to? Again, 177 is not a perfect square, so I'm going to find the perfect squares that 177 is in between. And looking back at my list of perfect squares again, 177 is going to be between 169 and 196. These two numbers are perfect squares. 169 and 196. That means now if I take the square root of 177, I'm going to be between the square root of 169 and the square root of 196. So the square root of 177 is between the square root of 169, which is 13, and the square root of 196, which is 14. Now, is square root of 177 closer to 13 or 14? Well, again, go back and look at the perfect squares of 169 and 196. 169 and 177 are 8 apart. 177 and 196 are 19 apart. So the square root of 177 is closer to the square root of 169, which is equal to 13. The square root of 177 is closest to 13. In our next example, they want us to solve for x in the equation x squared equals 100. Okay, so right now x is being squared and it's equal to the value of 100. And in order to get the value of x, what we would need to do is take the square root of x squared. Remember that taking the square root is the inverse of squaring a number. So if I had x squared there to figure out the value of x, I would need to do the square root of x squared, which means on the other side, because this is an equation, I also need to do the square root of 100. Remember, what you do on one side of the equation, you need to do on the other side of the equation. All right, so I have to ask myself, what number multiplied by itself would be equal to 100? Well, that's a pretty easy one. I know that that value would be 10 because 10 times 10 equals 100. So 10 squared equals 100. All right, that means that the square root of 100 is equal to 10. But this isn't the only answer, okay? In fact, if we think about it, we could also say that negative 10 multiplied by negative 10 is also 100. A negative times a negative, remember, is a positive number. So negative 10 squared is also equal to 100, which means to this example, there are two answers. X can equal 10, but X can also equal negative 10. To show that it could be either positive or negative, we write the symbol plus or minus. Plus or minus. X can equal plus or minus 10. Okay? All equations of the form x squared equals p, where p is some positive number, they have two solutions, a positive and a negative one that have the same absolute value. In this example, positive 10 and negative 10 are the two answers. Both of those numbers have the same absolute value. To prevent confusion about which number we want, the positive or the negative, the mathematical community decided that when we see the square root symbol, we will always give the principal square root, which is the positive answer. Okay, so when I ask for the square root of 100, I'm going to take 10, positive 10, as my answer, even though there are technically two different answers. This means that whenever you see something like the square root of 49, you should know that we only want the positive root, which would be 7. 7 times 7 is 49. Negative 7 times negative 7 is also 49. If we want the negative root, it will be written like this. Negative the square root of 49 is equal to negative 7. Okay, so if I only have a square root symbol like up above here, square root of 100, or right here, square root of 49, I'm really only going to ask for the positive answer. Now that we have a good idea of square roots, we're going to move on to cube roots. Just as with square roots, cube roots are the inverse of cubing a number. We are asking what number cubed, or meaning to the third power, is equal to the original number. The term cube comes from finding the volume of a cube. If a is any non-negative number, then the cube root of a is shown by this symbol right here. It looks very similar to a square root symbol, except there's a little 3 right there, which is indicating that we want the cube root. All right, so that's the symbol for a cube root. And it's the positive number that when cubed or multiplied by itself 3 times results in the value of a. Notice that a cube root does not have two answers. It's not positive a and negative a, it's only positive a. There are not positive and negative cube roots. Each cube root only has one real number solution. In example 4, they want us to evaluate each cube root and justify the answer with a product. So in question A, what's the cubed root of 64? Okay, well, just like with square roots, we had a chart that we were able to find with our cube roots on it. I want to know what's the cube root of 64. And so if I look at my chart here of my cube roots, okay, I'm looking for 64 in this column right here, and I see 64 right here. The cubed root of 64 is equal to 4. The cubed root of 64 equals 4. Justify your answer with a product. Well, that means that 4 times 4 times 4, all right, the number itself multiplied 3 times is equal to 64. 4 times 4 is 16, and 16 times 4 is 64. So 4 cubed is equal to 64. All right. Letter B asks, what is the cubed root of 8? Well, if I look at my chart, again, the cubed root of 8 is going to be equal to 2. And again, I'll justify that with a product. 2 times 2 times 2. All right, if I do 2 times 2, that gives me 4. And 4 times 2 gives me 8. So 2 to the third power, or 2 cubed, is equal to 8. So the cubed root of 8 has to be equal to 2. Finally, in letter C, the cubed root of 1,000, and that's going to be equal to 10. My product would say 10 times 10 times 10. 10 times 10 is 100, and 100 times 10 is 1,000. That means that 10 cubed equals 1,000, so the cubed root of 1,000 must be equal to 10. Our next example asks, why isn't the cubed root of 27 equal to negative 3? Okay, so remember, if we're going to cube a number, we're going to raise it to the third power. So negative 3, if I were to raise that to the third power, that means I'm going to do negative 3 times negative 3 times negative 3. All right, well, negative 3 times negative 3 I know is 9. And then 9 times negative 3 is equal to negative 27. which is not equal to positive 27. Okay, recall earlier we said that a square root can have a positive or a negative answer, but a cube root is only going to have one real number solution. Okay, so the cubed root of 27 is going to equal positive 3 because 3 times 3 times 3 equals 27. All right, it is only positive 3 and not negative 3. This means that we can take the cube root of negative numbers. So the cubed root of negative 8 equals negative 2 is a true statement. Because again, if we take negative 2 and we cube it, that means negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is 4. And 4 times negative 2 is negative 8. So it is possible to do a cube root of a negative number, but you can't take the cube root of, you can't take the square root of a negative number. Our next example says to explain why the cubed root of 72 is between 4 and 5. All right, so this is like when we were doing with the square roots, between which numbers was it between. 72 is not a cubed root. If we were to look at our chart of the perfect cubes, all right, 72 is not going to be on that list. Here's our list of perfect cubes. But I can look for the perfect cubes that 72 is between. 72 is between 64 and 125. Those are two perfect cubes. All right, so 72 is between 64 and 125. So if I do the cubed root of 72, I'm going to do the cubed root of 64 and the cubed root of 125. This means that the cubed root of 72 is going to be between the cubed root of 64, which is 4, and the cubed root of 125, which is 5. So that shows why the cubed root of 72 is between 4 and 5. In our final example, we're going to look at how we can do a cube root on a calculator. Okay, so a lot of you have the calculator that looks like this right here, and we knew to do the square root, we would have to hit the second button and then the x squared button. All right, in order to do a cubed root, the first thing that we have to do is type in the number 3. Then the cubed root, or in this case, any root symbol, is right here above this caret symbol. So that button right there is the caret symbol. Right there, it looks like the square root symbol, and there's a little x right there. X is equal to the number that you type in first, which in this case, we typed in 3. So we're going to do a cubed root. So I've got my number 3, and I'm going to hit second, and then I'm going to hit the cubed root button, which looks like that. And then this asks us to find use the calculator to find the decimal expansion of the cubed root of 72. So there's my cubed root of 72 equals, and there's my decimal. I'm going to write out that entire decimal display. All right, so let's do that right here. The cubed root of 72 equals 4 and 160, 167646. That is the decimal equivalent of the cubed root of 72 from our calculator. What they would like us to do is round your answer above to the following place values and then cube the rounded answers to see the effect of rounding. So we're going to take this number right here and we're going to round it to the nearest tenth, the nearest hundredth, and the nearest, we're going to make that 10,000th. All right, well, let's do the 10th place first. Okay, this number to the nearest tenth is about 4 and 2/10. Right now it's a 1/10, but that 6 is going to bump us up to about 4 and 2/10. Now I'm going to take this rounded number and I'm going to cube it, or raise it to the third power. So again, I'm going to take out my calculator, 4 and 2/10, and then I'm going to hit that caret button right there, and I'm going to raise it to the third power. And there's my answer, 74 and 88 thousandths. 74 and 88 thousandths. Notice when we take the rounded value of the cubed root and cube that, we get an answer that's close to our original cube root. All right, we did the cubed root of 72. This rounded answer cubed is 74 and 88 thousandths. So not too far away from 72, all right, but a little bit higher. Let's see what happens when we do that with the hundredths place. All right, our cubed root to the nearest hundredth is 4 and 16 hundredths. That 0 is not going to round us up. 4 and 16 hundredths. Let's cube that number now. All right, 4 and 16 hundredths. Raise it to the third power. And look at that decimal. Let's write out that whole thing. 71 and 991,296. All right, so if we go a little bit further with our rounding and we cube that number, notice that our cubed answer is much closer to what we started with here with 72 than this number was. Okay, so the more place values we take, the closer we should get to that number underneath the cubed root symbol. Let's do the 10,000ths place. Okay, to the 10,000ths place. Well, that 6 right there is going to bump this 1 up to a 2. So it's about 4 and 1,602 10,000ths. Let's go ahead and cube that number now. 4 and 1,602 10,000ths raised to the third power. And let's go ahead and put that in. 72 and 0,0167986. So once again, much closer than what I originally started with. Okay, I'm getting closer and closer to the number underneath the cubed root symbol, the more place values that I take.